A mathematical theory or system is expressed in logic by providing three ingredients: its syntax, its semantics, and its intended interpretation. The syntax and the semantics are formal, and their study is the main subject of logic. The requirement of being formal is essential to pursue a mathematical study. The syntax is the way to write things down. For example, in arithmetic, the syntax allows to recognize when a string of symbols is an expression or a formula. Also, proofs have a grammar defined by the deductive system. We reserve the word syntax for the grammar of the language plus the deductive system. The intended interpretation is the way in which we informally understand a theory. For example, in arithmetic, expressions stand for numbers, formulae are either true or false, and proofs are arguments justifying the conclusion when the assumptions hold. But what are integers? How do we decide whether a formula is true or false? When could we trust a proof's argument? The semantics is the way to attribute a meaning to a syntax. For example, in arithmetic, we could say that integers are the free group on one generator, that expressions are constructed as transformation on this group, and that formulae represent subsets of this structure. Truth means non-empty. What we want is a semantics that simulates the intended interpretation and a good agreement with the syntax.